Hey everyone, welcome back to my channel EduVibe. In today's lesson, we're discussing about the wave-particle durability, which we have focused on the photon momentum. So that's we have a formula for this, and we have just do the calculation in this, and know something about the theory in this too. So let's start with this topic with some theory part. Okay, the photon electric, the photoelectric, and the photon, then the quantum effects demonstrates the light and particle-like properties. So they both tell us that the particle-like properties they have a light. But we also saw light has the wave-like particle that in the quantum effect you can see this. Light have both things. The wave-like particle properties you can also see from the diffraction, polarization, and the interference too. This thing is known as the wave-particle durability. That wave and particle have the both the things. Light is the both. Light is behaved as a wave and the particle. We conclude this thing in the last lesson, which is the next lesson. Light is neither a wave or nor a particle, but either it is a both. It might be both, but not like we confirm like yeah, it just depends on how we observe it, decide to interact with it. We have one formula called the de Broglie experiment. Came to this idea trying to gather the concepts of momentum and the wavelength. He will able to come to the following formula, which is the wavelength is equal to the Planck's constant upon the magnitude of the momentum, which is the momentum. So they come to about the momentum thing. P is the momentum, this is the wavelength, and we have a Planck's constant. We always use this value. We can't use the other value of EV dot second. We always use this value. We not have options now. We have to use just this value for photon momentum. This thing is called the photon momentum, and the physics principle is the principle 9 in your formula sheet, which is the wave particle durability formula. So that's the core thing from this, that light is either be a neither a wave nor a particle. So this all thing we have to discuss in the next lesson for now, but we have to just know something this now. So for the photon momentum, which is the main part of this, so photon momentum, when determine the momentum of a photon too. Although the photon may not have mass, it does have a energy. It always have the relation between the momentum and the energy of the photon. So I have to come to know about this, that E is equal to the momentum times C. C is your speed of light, E is the energy of the photon, and P is the momentum of the photon. That's this. This thing is only valid for photons, not for anything else. We come to know about the other formula, which is the de Broglie's wavelength formula and the Planck's constant. So what is Planck's constant? Hc upon wavelength. So from here, if you can like hc upon wavelength and times c, you will get E is equal to PSC, because this no, from here, if we like convert this something, so P is equal to h upon wavelength. So here you can see that E is equal to the PEC. That formula can be made like this thing. That thing you have to know, and this is your new formula. This is also in your formula sheet. That two formulas you have to know, this one and this one. This formula I actually made from that. So that's only the formula you have to know, not the derivation like thing. So that's all thing. So let's move on to question with some one simple question, like we're doing the momentum and impulse, but with that part of the photon momentum now. Determine the wavelength of the 100 kg person who walks with the speed of 2.00 meter per second. So we don't have momentum, but we have to find the wavelength, which is equal to h upon p. 6.63 into 10 raised to power minus 34 joules per second. Momentum can be found over there. We know momentum is equal to mass times velocity. Mass is 100 kg. Speed is 2.00 meter per second. You will get about 200 kg dot meter per second. Put this over there and get your answer. This should be 200. So wavelength you get about 3.32 into 10 raised to power minus 36 meters. That's your wavelength. There's an easy question. You get the more complex one like this. The momentum of a dental X-ray photon is this. 3.0 kg dot meter per second. Tell me the minimum voltage required to create this S-ray in a cathode ray tube by the accelerating the electrons between the charged plates. You may assume that energy of electron is completely converting the energy of the S-ray photon. You have to find the what? Find the minimum voltage, which is V. So from here, they talk about like parallel plates accelerating the electrons between the charged plates, and they calculate all the energy of the electron can continue the energy of the S-ray photon. So if you have anything like you have a like talk about the energy in that the accelerating thing, they telling about the electrons and want the voltage, which means that potential energy is all can be converted or all can be equal to the energy of the S-ray photon. This is equal to E times voltage, and this is equal to the P times C, which is momentum times C. So this is equal to the PC upon Q. Now you have to just put the things in. 3.0 raised to minus 23 kg dot meter per second. C is 3.0 10 raised to power 8 meter per second. This whole thing is equal to Q. Q. Now Q is the charge, so you can say this is your charge from the formula in coulombs, and this is equal to 5.63 into 10 raised to power 4 volts. You can solve like this. So this is the like a thing you have to know for the extra. There's something like question you get from like forces and fields of the charged place. So that formula is also used. So again, that whole topics are coming. In the last unit, we all collect all 3 units into the 1 unit now. So that's for all for this lesson for the photon momentum. So that session is important for the next lesson too, because we're doing the light overview, which we conclude that how the light is behaving. And we're also doing some momentum questions again with the electromagnetic radiations, with the photon momentum, and all the things we covered now. So in next lesson, we start doing the last topic of this lesson, of this chapter. So that's all for this lesson for now. Like me say, where do vibe, learn smarter, not harder. Please like, share, and subscribe to my channel. If you have any questions, let me in the comment section. See you in the next lesson. Till us, you get with EduVibe.